Hello everyone. So today, welcome to today's LeetCode problem, which is the power of 2. So here we are going to check if a number is actually a power of 2 or not. So we have to check if there exists an integer x such that n is equal to 2 to the power x. So if n is equal to 1, we see that 1 is the power of 2 because 2 to the power 0 is 1, so we return true. So the first approach that we can follow is that our first approach will be to continuously divide the number by 2. For example, we are going to take 16 as our n. So this time we take 16 and we are going to divide 16 divided by 2, and then we are going to get 8. 8 divided by 2 we are going to get 4. 4 again we divide by 2 and we are going to get 2. 2 we are going to divide by 2, and finally we are going to reach the number 1. So our final destination is 1. However, when we consider 12, we divide it by 2, we get 6. 6 divided by 2, we get 3. However, 3 divided by 2, it's not a number which is divisible by 2. And so we're going to get an odd number in case of a number, in case of considering a number that is not a power of 2, that is 12. So 16 is a power of 2 because 2 to the power 16. So 2 to the power 4. 2 2s are 4, 4 2s are 8, 8 to 16. So that is a power of 2, and hence we are going to get 1 as a result. However, 12 we are not going to get 1 as a result, we are going to get an odd number. So using that we're going to code it. So if n is equal to 0, then we return false, because 0, if n is equal to 0, then 0 is not a power of 2, so we return false. While we're going to get inside a while loop, we're going to check if the number is divisible by 2 and the remainder comes out to be 0. If so, then we keep on dividing it by 2. So the while loop goes on for a while, and then after that, whatever answer we get. So for example, if we get 1, then we return if n is equal to 1. So 1 is equal to 1, so we return true. However, if we get 3 as our n final answer, n is equal to 3, then we are going to return n is equal to 1. 3 is equal to 1. No, it's false. So we're going to return false. So if we run this and check that, we're going to get 17 as our as our input, as n is equal to 17. So that will be we're going to get false, because finally it's not divisible by 2, and we're going to get an odd number. Like we got 3 here, we're going to get an odd number over there as well, so we got false. Another approach will be, a second approach is bit shifting. So what is bit shifting? So we're going to take the same number 16, and 16 written in binary format will be 1 followed by 4 zeros. So this time we're going to use the AND operation. So 10,000 and 1, we're going to take 1 here, 1. So 10,000 and 1, what will be the answer for that? So that will be 0 and 1. We check, we get it as 0. And now what we are going to do is, we are going to right shift our binary number. We are going to right shift 16. So this means that when we right shift 10,000, we are going to get 1,000. So 0 vanishes, so 1,000. So after right shifting, we get 1,000, 1,000 and 1, we are going to get 0 again. Then again right shift, then 100 and 1, we get 0 again. Then 10 and 1, we are going to get 0. And finally 1 and 1. So what happens at 1 and 1? We are not going to get 0, we are going to get 1. So this time our n will become 1. That will be our final n value. In the case of 12, which is not a power of 2, written in binary format, it is 1100. So this time we are going to add it with 1 again. So 1100 and 1, we are going to get 0. And 110, after right shifting, 0 disappears and it will be 110. Then 110 and 1, what are we going to get? We are going to get 0. 1 1 and 1, we are now going to get 0. So 1 1 and 1, because 1 1 is n is equal to 3, we're going to get n is equal to 3. So n is not equal to 1. So that is an approach that we can use. So going here and coding that one, I'll just comment this one out. Okay, it's gone. So here we're going to use the same if n equals 0. That is the same, because we're going to return false for all. Then while n is greater than 1, and then and 1, then we're going to right shift our n by one place. Then finally we are going to return. We are going to check if n is equal to 1 using our ternary operator. Then we return true if n is actually equal to 1. Else we are just going to return false if it's not equal to 1. It's equal to some other number like 3. So what this is actually doing is that, so we have a, put the bracket here, we are given an n, we are checking if n is equal to 0. If n is equal to 0, then it is not a power of 2. Then we keep shifting the bits unless and until n is hitting 1. If it is hitting 1, we're not going inside the while loop. So unless and until n is hitting 1, or the least significant bit is not 1, then we will keep right shifting the n value over here. So this is our n value. We're going to keep right shifting it. That is unless and until n is hitting 1, or the least significant bit is not 1. So if the least significant bit is 1, and if our least significant bit, that is LSB, is 1, and our n is hitting 1, then we're not going to go inside the loop. We're just going to terminate it and we're going to return it. So if n is equal to 1, then we're going to return true, else we're going to return false. So that is what this is about. Our final approach is using logarithm. So using logarithm, we can see that there are two concepts here, seal and floor. So what is seal and floor? Let's just take an example of a decimal number. The ceiling of 3.7. Whatever the ceiling means is that it's going to take the largest, that is closest to 3.7. So what is closest to 3.7? That is 3 and 4. But however, we're going to take 4 because it is the largest value that is closest to 3.7. Floor of 3.7 means we're going to take the least that is closest to 3.7. So that will be 3. We're not going to take 4 because we're going to take the least value. So seal means like ceiling, like the topmost, the highest number that is closest, that will be 4, and floor means the bottomest, so that will be 3. So that happens when with a decimal number. So what happens in this example is that we are going to take the seal of log of n base 2. So what is log of n base 2? Log of n base 2, if we are going to take a log of n as something that is a power of 2, then we are going to get an integer value. However, if we take a number that is not a power of 2, that is m here, for example, it's not a power of 2, then we are going to get the log value as a decimal value. In case of a number which is a power of 2, we are going to get the log value as an integer value. This is a decimal value. So using that, we can just use to manipulate our code. So for 16 is a power of 2, so we are going to get an integer value, but 12 is not a power of 2. And here, hence, since it's not a power of 2, the logarithm of 12 will be 3 point something, which is a decimal number. So we know that seal and floor of a decimal number differs. That is, see, seal of a decimal number that is 3.7 is 4, and floor of a decimal number 3.7 is 3. So 4 is not equal to 3. However, if we take a seal of 4, we get 4. Floor of 4 is also 4. So seal and floor of a integer number will be same, but seal and floor of a decimal number will never be the same. So using that, we can see that seal of 16 is 4, floor of 16 is, sorry, seal of logarithm of 16 is 4, and floor of logarithm of 16 is 4. But seal of logarithm of 12 is 4, and floor of logarithm of 12 is 3. So finally we're going to check that if seal and floor are the same, then that means it is a number that is a power of 2. If seal and floor are not the same, that means it's not a power of 2. So we can use that here to code it. So what happens here is that we're going to check the same condition actually. N is equal to 0, then we're going to return false. Then we're just going to have just one line of code. That is just checking. We're just going to check if the floor and seal are the same. That's it. So return floor of log base 2n. So if is that equal to seal of log base 2n, is it equal? So using our question mark, and it's true, else it is false. So we see that yes, 17 is not a power of 2 and it returned false. So this is another approach that you can use. Thank you.